Okay. Are humans causing changes in climate forcing agents? Is C equals true? Okay, so we go to part C, drivers of climate change. And again, not only greenhouse gases, but ozone levels and aerosols and land use, and we've affected climate in lots of ways. Here's the bottom line. Total radiative forcing is positive and has led to an uptake in energy by the climate system. The largest contribution to total radiative forcing is caused by the increase in atmospheric concentration of CO2. That part has not changed. Okay, 7 years, CO2 levels are still increasing. They have the Mauna Loa data in this report. I really like the way that they put all those greenhouse gases in the AR4 report, and you can really see the percentage increases, but they didn't have that here. Along with the CO2, you can see that more CO2 is dissolving in the oceans, and the pH of the ocean is decreasing by maybe 1/10 of a pH unit. The problem there isn't necessarily that the ocean is going to be acidic. The ocean, a pH of 8, is still slightly alkaline. It's not acidic. It's the opposite. But as the ocean gets more acidic, carbonate, which is CO3 minus 2, which corals and mollusks and things like that use to build their skeletons, becomes disproportionately unavailable. So they're thinking that this might be one of the things affecting bleaching of coral reefs, and it's going to make life harder for things that need carbonate to build their exoskeletons with. So that's a factor of climate that people are going to be talking more about as things go forward. You're still moving slow here. Okay, even though it's the middle of the video, I'm going to try to quit some applications here to speed my computer up. No. No. Quit. Okay. Okay. Annual CO2 emissions from fossil fuel combustion and cement production, 8.3 gigatons per year for that period averaged over the last 10 years or so, going back to 2011, and up to 9.5 gigatons or petagrams per year. So I keep having to update that slide of mine on do human sources rival nature? Okay. And here they know more about where it's going now, too. 240 gigatons accumulate in the atmosphere, 155 are taken up by the oceans, and then 160 are taken up in natural terrestrial ecosystems, okay? The cumulative residual land sink, that's trees eating the stuff and building wood, which is good. Thank you for the trees. Ocean acidification is quantified by decreases in pH. This is a 20% increase in the acidity. And again, it's still not acidic yet. The real effect there is that as we increase the acidity, it makes carbonate less available there. So we have to update this. Do CO2 sources rival nature? Yes, fossil fuels and cement production. Now 9.2 petagrams per year. Okay, so now we're, much more than 10% of the terrestrial biosphere, which was my nice benchmark, or about 10% of the marine biosphere, or, getting close to, 1/15th, okay, which is, 7%. So there we go. Okay. Here, this is my AR4 graphic. I said I like this. We're still looking at, a 40% increase in CO2, 150% increase in methane, and a 20% increase in nitrous oxide. And again, this is the AR4 picture, but these are the AR5 numbers. So notice that CO2 went from the 30-some increase to a 40% increase. And again, sustainability. If we're living a sustainable lifestyle, we're not rapidly increasing the concentration of these gases in the atmosphere. They are level and stable, and we aren't there. So. Okay. Emissions of CO2 have caused a radiative force of about 1.68. That's about exactly the same number that's in the AR4. Methane has caused a larger radiative forcing than we thought, and that's because there's some secondary effects, okay, beyond the carbon, just methane itself. Methane, does some chemistry in the atmosphere and causes some other things, and this is one place where the science has improved. Halocarbons are still a problem. Interesting, the ones from CFCs have gone down a little bit, but from those CFC substitutes, it's come up. So there's a little bit of a trade-off there that's kind of canceled out. Halocarbons are still a significant factor. And now they've included some short-lived gases that contribute to the radiative forcing. Remember, I sort of rule these out as greenhouse gases in the way I teach this. And now the science is complex enough to include some of these things that don't hang around a long time. And there's actually a significant part of this. So this is the updated version of this, which is it's kind of a mouthful. So the top one are these well-mixed, long-lived greenhouse gases. CO2 warms the planet. Very high level of confidence or level of scientific understanding. Here now, if you look at the methane, you'll see, so there's the methane from methane absorbing infrared radiation and methane acting as a greenhouse gas. Methane, some of that gets up to the stratosphere to make water vapor. There's not a lot of water vapor in the stratosphere, but it's increasing. A little extra water vapor in the stratosphere has enhanced the greenhouse effect due to that. When methane decomposes in the atmosphere, it makes tropospheric ozone. Ozone is a greenhouse gas. There's that. And ultimately, when methane is completely oxidized in the atmosphere, it's turned into CO2. There's a little brown stripe there. So again, this is the part from methane. This is the part from the chemistry that methane undergoes as it decomposes in the atmosphere. Okay, so they combine not only the radiative forcing of the direct part, but then all the chemical byproducts into one bar here. And I think it's great as somebody who understands some atmospheric chemistry. I'm not convinced it's the best way to sell this to politicians or people in a 100 level class, but that's what we got. So again, and then with halocarbons, this is the direct effect due to the CFCs, and then this cooling effect to the left is a depletion of stratospheric ozone. Stratospheric ozone is a greenhouse gas just like tropospheric ozone is. So there's a little cooling effect. And again, a bar this way is a warming effect and a bar this way is a cooling effect. Nitrous oxide about the same. Okay, here are the short-lived guys here. That stands for carbon monoxide. This is for NOx. You know, that air pollution stuff like that the dog from Cleveland was giving us. And then this is non-methane volatile organic compounds, other carbon-based compounds beyond methane. And, you know, they have a little warming effect, and, you know, they produce some tropospheric ozone, some tropospheric methane, and some tropospheric CO2. CO emissions enhance methane a little bit, cause a little ozone in the atmosphere, and ultimately get oxidized to CO2. So they have a, you know, that's nothing compared to this stuff, but it's still a pretty significant amount. So again, the science is getting into the details here. That's the good news. None of this was here in the AR4, and it's, you know, and it's significant. And then, you know, these NOx emissions, part of their deal is that they cause nitrate aerosol. So these NOx emissions still cause cooling more so than the ozone that they create. And they've separated them out from the aerosols because they're kind of a double whammy, a lot of cooling and a little bit of warming. And then here's all the other kinds of aerosols, all right? And the main ones that I talked about here were this sulfate aerosol, which is kind of lime green here. There's some mineral dust kind of blowing off the desert, and then there's these organic and black carbon aerosols from like diesel exhaust. That's really new knowledge. And then, the organic carbon is a cooling effect because that stuff get oxidized, but the black carbon, like the diesel exhaust and from coal burning power plants. And notice that the level of confidence in this went from low in the AR4 to high here. So this is one of the key places that they've made some progress. And so we understand the aerosols better. The part that we understood before the sulfate is still a major cooling effect, but now we understand that there's this big black carbon warming effect. And it's good news that we understand this stuff better, and this is still a pretty difficult stuff. The one place that's really low in scientific understanding is this indirect aerosol effect. These particles cause more clouds. Clouds increase albedo, and so on and so forth. The surface albedo is still a medium understanding, but a relatively small cooling effect. And this is another major development in the AR5, is changes in solar irradiance, okay? This estimate has gotten very small, and the error bar has gotten small, and the level of scientific understanding has gone from very low to medium. We still only have a few decades on solar irradiance, but it really does not look like changes in solar irradiance are causing a lot of the recent climate change. And there are still tons of people, including a lot of dishonest politicians, telling you that sunspots cause climate change. And this error bar right here is very much in disagreement with that. Everybody may be entitled to their opinion. This is the opinion of the mainstream scientific community. And so here's your total anthropogenic forcing. That's what we got from humans to 1950, that to 1980, that to 2011. Notice now that this total anthropogenic forcing is no longer accidentally equal to the total CO2 part. Some of these other things are a factor. So I think we can say that C is equal to true here. Still equal to true. Okay, home stretch here, gang. Is there evidence of a mechanistic relationship, or, what's different about making this statement in the AR5? Okay, again, we know carbon dioxide is a heat-trapping gas, and I think that's mechanistic evidence, and so on and so forth. And again, we had this conversation about, most people regard scientific fact as something based on experimental evidence. We can't do that experiment here. We don't have a control Earth, and we talked about the moral aspects of putting a bunch of carbon dioxide in the atmosphere and seeing what happens. In my experience, most students have decided that would be an immoral thing to do, in spite of the fact that we're sort of engaged in that experiment anyway. So this is going to rely on model data, and I'll just say now that the modeling has improved in terms of spatial resolution and in terms of quality of reproducing the data, especially early in the 20th century, which was kind of off the mark in the last report. Okay, so again, we're working our way through this argument. Okay, for this to be true, first of all, our cause and our effect need to be true. We've determined that. And now we're in search for some kind of mechanistic relationship that we're going to find in part D of this report. Okay, here's the bottom line. Human influence on the climate system is clear. This is evident from increasing greenhouse gas concentrations in the atmosphere, positive radiative forcing, observed warming, and understanding of the climate system. So this is saying, hey, look at observed warming, C is true. Observed warming, T is true. Increasing greenhouse gas concentrations, positive radiative forcing, C is true. Understanding of the climate system, mechanistic relationship. In other words, they understand the connections between these at a reasonable level at this point, given the complexity of the system. Climate models have improved since the AR4. Models reproduced observed continental scale surface temperature patterns and trends over many decades, including the more rapid warming since the mid-20th century and cooling following the large volcanic eruptions. Very high confidence. Okay, so they have the scientists have and not just the guys that build the models. They have a lot of confidence in these climate models. People in the community do. And again, what that confidence means is that we're up here. So this is sort of a confidence chart. So the confidence scale, if it's dark here and we're very high confidence, that means the type, amount, quality, and consistency of the evidence is high, and the agreement between the models and the explanations is high. So this isn't just one person's opinion. There are multiple studies and multiple sets of data producing agreement between things here. And that's what that very high confidence means at this point.